Another common base that's used on a logarithm besides base 10 is going to be this base e. And e actually is not a variable, it's a number, and it's equal to 2.71828, and it continues. The number is irrational, and irrational means it will never terminate, meaning stop, or repeat. We're going to use this as a base besides base 10 in logarithms because this number, what it does is it occurs naturally. It occurs naturally when we have this thing called continuous growth or decay. So my rate isn't just going to be figured one time a year or two times a year, it's going to be figured continuously. So we have a formula for this, and it's the amount I end up with is equal to the amount I start with, e, this number 2.71828, etc., raised to the r, the rate, and the time. So let's just see what happens when I compound continuously. Now when you compound, what happens is you're calculating interest on interest. So if I'm compounding yearly, the amount of money I get is equal to my initial investment, the 1 plus my rate, to the amount of time. So in this case it would be 100, and converting my 5% to a decimal, and I have 20 years to find out the value. And let's see, on a calculator, again we need to use a calculator to compute this. I'm going to take an order of operations says use your exponents first. So I'm going to raise that to the 20th power, and then I'm multiply by 100. And my end result will be $265.33. So let's go ahead and we'll write that down. $265.33. Now, if I'm going to compound quarterly, it's a little bit different story. I get interest on the interest. So again, I'm looking for the amount after I start with $100, 1 plus. And what happens here is I take my rate divided by n, where n is equal to the number of compounds. That just tells me the bank is going to figure interest every year 4 different times. And so I get a little bit of interest the first time, and then the next time they compute interest, I get interest not only on my initial investment of $100, but on the other little bit of interest that I got from the first compounding. And this formula then shows this rate divided by n, and then it's raised to the nt. So computing this, I'm going to have $100 invested, and it's going to be 1 plus my rate divided by 4, because quarterly means 4 compounds, and 4 times 20. So I get interest not computed 20 times in this year. I get a total in those 20 years, not just 20 times, but 80 times. So plugging this into the calculator, we have to be a little bit careful of our order of operations here. We want to first compute what is inside the parentheses. So I'm going to start with taking this rate, dividing it by 4, and then what we'll do is we'll add 1 to that, and then this is taken to the 80th power. 4 times 20 is 80th power, and then finally we'll multiply that by 100. Now notice when it was configured once a year, I got that $265.33. In this one I get $270 and about 15 cents. So here I had this $270, and we'll round it to 15 cents. And over here I had $265.33. So the same amount, the same time, the same interest, it just figured more often. I get interest upon interest. Now, when I compound continuously, The formula that I was using earlier was this: A equals my investment, 1 plus R over N raised to the NT. Well, this formula merges into what we call the PERT formula when it's compounded continuously. So the amount I want to end up with here is going to be my initial investment, E, the rate, again converted to a decimal, times the amount of years, which is 20. So let's see what happens here. It seems to me that it should be more because I'm getting interest calculated more often. And so when interest is calculated, it's on the interest that I received from the earlier time it was computed. So I'm going to take 100, and there is an E here on the calculator. On the calculator, it's this second ln button, and notice it raises it to a power. It knows that I'm going to put in 0.05 times 20. So that's the exponent on E. And when I see what I get here, I get $271.83. $271.83. So you can see that I actually receive more money the more compounds, and if it's continuous over and over and over and over again, you're going to get the most money.